Imagine a dawn like this. A section of the Beijing-Hong Kong-Macau expressway, the great economic artery running through China from north to south, is unusually quiet. There are no human shouts, only the whisper of the wind brushing across the asphalt. Yet, in this darkness that stretches to the horizon, a silent revolution is unfolding. 10 steel behemoths, with a combined weight of over 200 tons, operate in concert with an almost mystical rhythm, like a ghost fleet from the future. The paver's massive screed extrudes black asphalt, smooth as a mirror. The fleet of road rollers that follows compacts the newborn road surface over and over. What is most startling is their drivers' cabs. They are completely empty. There are no sweat-drenched workers here. In their place are the blinking server lights of a data center hundreds of kilometers away and streams of data traversing the 5G network at the speed of light. This is not the grand narrative of a sci-fi director, but the world's first truly end-to-end, fully unmanned road paving cluster operation. This 157-kilometer stretch of road is less a highway and more a monument. It heralds not only the birth of a construction method, but also the end of an era. The Infrastructure 1 era that relied on human labor, sweat, and experience. What we are witnessing is the fundamental rewriting of the underlying logic of a multi-trillion-dollar global industry. And the prelude to this disruption began a decade ago, with a national-level traffic trauma that nearly caused a total blockage of this great artery. We must rewind to the National Day holiday in 2015. An aerial photograph, like a precisely dropped shockwave bomb, detonated global public opinion. Near the entrance to Beijing, the returning traffic was abruptly compressed by a design bottleneck, with 50 lanes narrowing to just 20 in an instant. The result was catastrophic. Millions of vehicles were welded to the road surface, forming a solidified iron thrombus stretching for tens of kilometers. Over 7.5 million people, eager to get home, were trapped in this massive parking lot, unable to move forward or back. The problem exposed by this traffic jam was far more than just short-sighted road planning. It was a brutal stress test, ruthlessly revealing the fragility of the traditional infrastructure model in the face of modern society's extreme peak demands. China could build bridges, tunnels, and highways at an unprecedented speed, but there was clearly a huge gap in the wisdom of using and managing these vast assets. Decision makers realized that China didn't just need more concrete. It needed a smarter neural network and the revolutionary new methods to create it. The visceral pain of this scar ultimately evolved into a powerful national will. If the previous infrastructure mantra was, to get rich, first build roads, then the new national strategy became, to be strong, first build the network. A new infrastructure network integrating 5G, artificial intelligence, big data, and the industrial Internet of Things. In the 5 years that followed, China poured a massive investment of over 10 trillion RMB into the new infrastructure sector. In this grand national narrative, traditional manufacturing giants like Sany and XCMG were given a new historic mission. They were no longer to be just forgers of steel, but also writers of code and tamers of algorithms. Sany assembled its top algorithm engineers, software architects, and mechanical design experts to form a special task force legion. They spent more than 5 years solving what seemed like a simple yet profoundly complex problem: how to quantify the feel, experience, and intuition of the best human road builders into code that machines could understand and execute flawlessly. This unmanned operation on the Beijing-Hong Kong-Macau expressway is the answer they delivered. Under the traditional construction model, a similar project would require a team of several hundred people. Now, the direct on-site manpower demand has plummeted by over 70%, with only a handful of core managers needed. Even more remarkably, the overall construction efficiency has soared by 40%. This is not a simple case of machines replacing humans, but a well-thought-out industrial dimensionality reduction strike, driven by national strategy, from top-level design to core technology. Now, let us become a data point and dive into the neural network of this ghost fleet to uncover the secrets of its extraordinary capabilities. The operation of this cluster, composed of a 1+3+3+3 Formation: 1 core paver, 6 double-drum steel rollers, 3 pneumatic tire rollers, is as exquisite as a digital symphony performed by a top orchestra, and its conductor is an invisible artificial intelligence. Before this fleet ever embarked on its journey, a digital twin world, a one counterpart to the real one, had already been created. Using high-precision laser scanning and drone mapping, engineers perfectly replicated the 157-kilometer road section in virtual space with millimeter-level accuracy, including every inch of terrain fluctuation, soil density, and environmental parameter. The AI commander first conducted trillions of simulated construction runs in this virtual world. It deduced the optimal paving speed, the best compaction paths, and the ideal temperature controls under different weather conditions and material batches, ultimately generating a nearly perfect construction script. The real-world operation is merely the precise execution of this virtual rehearsal. This fundamentally subverts the traditional model that relies on on-site experience and adjust-as-you-go methods. If the digital twin is the script, then 5G technology is the neural network that endows this fleet with telepathic abilities. Each machine acts like a neuron, exchanging massive amounts of information at millisecond speeds through the ultra-low latency, ultra-high bandwidth 5G network. The paver's real-time paving thickness and asphalt temperature are instantly broadcast to all the rollers behind it. The position, speed, and vibration frequency of the first roller become the basis for the second roller's decisions. They are no longer isolated individuals but a hive with a collective consciousness. Based on this vast stream of real-time data, the AI commander performs thousands of global calculations per second, dynamically adjusting the actions of every unit to ensure the entire cluster moves in harmony, as if it were a single living organism. This swarm intelligence is far more efficient and precise than the walkie-talkie-based coordination of a human crew. A widely cited comparison is that while Caterpillar's CAT command system has also achieved single-machine remote control or semi-autonomy, what China has demonstrated this time is deep, cross-species coordination across the entire construction process and among multiple different types of equipment, a challenge of another technological dimension. The first violin of this symphony is the Sany ultra-wide paver, with a staggering width of 19.25 meters. Its ability to pave 4 lanes at once is a hardware marvel in itself, but its true soul lies in the integrated AI algorithm. At the core of this algorithm is the muscle memory of thousands of China's top paver operators. The R&D team spent years recording and analyzing the subtle control these masters exerted over the throttle, speed, and vibration frequency in various conditions. Through deep learning, the AI transformed this unstructured experience into a structured data model. As a result, when this machine operates, it can consistently control the road surface evenness error to within 2 millimeters, about the thickness of a coin. This is a stroke of genius that a human operator can only occasionally achieve under ideal conditions, but the AI makes it the norm every single second. The true killer app, however, is the zero-edge compaction technology in the rolling phase. The edge of a highway has always been its weakest point, with traditional compaction often leading to early damage from over-rolling or under-rolling. By integrating LiDAR and machine vision, this AI roller fleet can compact along the road shoulder with the precision of a ruler drawing a line, ensuring 100% compaction density without ever damaging the fragile shoulder structure. The benefits of this seemingly minor improvement are enormous. It directly reduces the standard deviation of the road's structural strength by 60%, which means the overall service life of the road is predicted to be extended by at least 20%. A highway originally designed to last 10 years might now serve safely for 12 or even 15 years. When this figure is multiplied by the vast mileage of China's highway network, the long-term maintenance cost savings will be astronomical. The audience for this technological ballet on the Beijing-Hong Kong-Macao expressway is by no means limited to the Chinese. On the other side of the Pacific in Illinois, Caterpillar's headquarters, and Tokyo, Komatsu's headquarters, as well as in the boardrooms of Europe's major industrial giants. The relevant videos and data are being analyzed frame by frame. This is not just a demonstration of engineering capability, but a clear declaration of geotechnical power. For the past few decades, the global calling cards of Chinese infrastructure have been China speed and China scale. But its core technology, especially in digitalization and intelligent software, has largely relied on the West. However, this unmanned cluster operation showcases a new, harder-to-replicate model: the deep coupling of top-tier hardware plus intelligent software plus closed-loop data. Unlike the Western approach, which tends to develop general-purpose construction management software to be adapted to different hardware brands, China is deeply burning AI algorithms into the central nervous system of its heavy machinery. Companies like Sany and XCMG have already built a formidable, fully independent and controllable industrial chain around high-precision sensors, onboard controllers, communication modules, and core algorithms. In this project alone, 2 petabytes of effective construction data were generated in just a few weeks. What does this mean? It's equivalent to 200 times the data volume of all the printed materials in the U.S. Library of Congress. This data contains invaluable information on countless variables in a real-world environment: temperature, humidity, material stress, mechanical wear. And it serves as the data oil to feed and train the next generation of AI algorithms. This creates a powerful positive flywheel. China has the world's largest and most complex infrastructure market, providing the richest training ground for AI. AI generates massive amounts of data in practice, which in turn further optimizes the algorithms, making the machines smarter. Smarter machines deliver higher efficiency and quality, thereby winning more projects and generating more data. While competitors are still conducting limited simulations in their labs, China's AI construction robots are already engaged in daily combat drills across the vast expanse of the country. This iterative advantage, based on real-world data, is forming an ever wider and deeper data moat. If we shift our gaze from this 157-kilometer highway to the more distant future, the significance of this technological breakthrough will extend far beyond infrastructure itself. It is opening up a new realm of possibilities for human civilization. In regions with harsh geological conditions and frequent disasters, when an earthquake or landslide destroys a lifeline route, a team of autonomous construction machines, without needing humans to enter the danger zone, can work around the clock during the 72-hour golden rescue window to quickly open an emergency road. In life-forbidden zones like the high-altitude, oxygen-deficient, and harsh environment of the Tibetan Plateau, robot construction teams can tirelessly complete mission-impossible projects, such as the China-Nepal Railway across the Himalayas. The boundaries of human engineering will no longer be constrained by the physiological limits of flesh and blood. An even more exciting picture is that future infrastructure itself will become an intelligent life form. By embedding billions of microfiber optic sensors and piezoelectric materials into asphalt and concrete, roads will be able to perceive their own health in real time, where an internal microcrack has appeared, where the subgrade is beginning to subside, or which section of the road has become slippery due to ice. This data will be instantly uploaded to a cloud-based infrastructure brain. The AI system will be able to accurately diagnose problems while they are still in their infancy and automatically dispatch unmanned maintenance vehicles to perform precise, microsurgical repairs on the lesions during periods of low nighttime traffic. The highway will transform from a passive, depreciating asset requiring periodic major overhauls into a living system that is actively managed, self-diagnosing, and self-sustaining. It could even communicate in real time with the intelligent connected vehicles driving on it, providing centimeter-level road condition information to help them avoid dangers, thereby building a true vehicle-road synergy, intelligent transportation network. When those 10 steel behemoths, their mission complete, turn quietly toward their next battlefield in the glow of the setting sun, the perfectly smooth black highway they leave behind is no longer just a physical path connecting two places. It is the glorious prelude to humanity's march into the era of autonomous infrastructure. an epic written jointly by code and steel.